descending order. So you are descending, it means you are on the top of mountain and you are declining, okay? You are coming down. So it's like this. You are here, okay, and you are coming. This is the floor. Okay, let's make this side the floor. So you are coming down. It means you are starting from the highest, okay? All right, so let's use the same analogy. We said once the denominators are equal, we are free to go. We just use the numerators to judge, okay? So we have 17, 7, 3, 11. Which one do you think is the highest among them? So we'll choose this one as our first fraction. So starting from the highest. Okay. So we have 17 on 10, followed by 11 on 10, followed by 7 on 10. Then we have the smallest. So we say we have arranged the fractions in descending order. Okay. Now, same way they can ask you to compare using the less than or greater than sign. So once it happens this way, and you find out that the denominators are equal, go by the same method. So when you ask to compare 5 on 10 and 3 on 10. So we have 10 here, 10 there. So we say the first one is more than the second one. So let me use this dot, okay? So we say this one is more than that. Right. Now, we want to talk about different denominators. Now, situation whereby denominators are not equal. For instance, when we have 1 on 2, 3 on 5, 1 on 10, 3 on 10. So if you're asked to arrange the following in ascending order, so be very careful here. Now, if you find out that the denominators are unequal, meaning the denominators are not equal, okay? Now, situation like this, you have to go by the LCM theorem. You have to find the LCM of the fractions. So you have to find the LCM of the fractions. And we know what is meant by LCM. When we talk about LCM, we mean the L stands for the least, the C common, then M is multiples. Okay, so let me start from this. Now I want to find the least common multiples of the numbers here: 2, 5, 10, 10. So let me start with 2. So I'll look for the multiples of 2. So 2, 1, 2, 2, 2, 4, 2, 3, 6, 2, 4, 8, 2, 5, 10, 2, 6, 12. Now, at times, look at the highest number here and make sure we get it inside here. That's the trick here. So let's go to 5. So 5 on 5, 5 to 10, 5 to the 15. Okay, the highest number is there. So the next one will be 10. 10, 1, 10, 10 to 20. So 20, 30 in that order. So look at the third set here. So look at this, that, and that. Look for the common among them, the commonest, okay? And that is the least common multiple. So if I start with 2 here, there is nothing like 2 here. We don't have it here. So 4, no 4, 6, no 6, 8, no 8. So we have 10 here, 10 here. And since this one starts with 10, I think the least common multiples here is 10. So we have 10. Now, after getting the 10, we just do this and put a 10 here. So I'll start from here. 2 into 10, or 2 times what number will give us 10? 5. Okay, 2, 5, 10. It means 2 goes into 10 5 times. Now, after getting that number, you multiply it by its numerator here, 1. So 2 into 10, 5. So we multiply the result by this 5. So 5 times 1 is 5, comma. 5 into 10 is 2. 2 times 3 is 6, comma. 10 into 10 is 1. 1 times 1 is 1. 10 into 10 is 1. 1 times 3 is 3. So we have 5, 6, okay, 1, and 3. Now we have aligned them here with a common denominator. So with this, we can proceed. If you're asked to arrange them in ascending order, you are free to go. If you are asked to arrange them in descending order too, you are free to go. Okay, so let's start with the ascending order. Ascending. Okay. Now with ascending from the smallest, look, we have 1 here. Okay, 1. And the 1 corresponds to this. So we have 1 over 10. Okay, 1 over 10. And the next one is 3. So the 3 corresponds to the last one, 3 on 10. And the next one will be 5, and that is half. And the last one will be 3 on 5. Okay, so we say we have arranged them in ascending order. That's how we do it. Okay, now we can pause the video and try the following. So arrange the following in ascending order. Okay, so 1, we have 5 on 3, 2 on 3, 7 on 6, 1 on 12, then 5 on 2. Okay, so we can try that. Let me add one more. So 7 on 4, 3 on 4, 5 on 3, 2 on 5 on 3, sorry. So we have 2 examples. So you can pause the video and then try them. All right. Okay. Now, when you are asked to compare fractions to, you have to go by the same method. Now let's solve the first one. So we have 5 on 3, 2 on 3, 7 on 6, 1 on 12, and 5 on 2. Okay. So let's solve the first one. Okay. Now, ask yourself, are the denominators equal? No. We have 3, 3, 6, 12, 2. So, denominators are not equal. So, we have to go by the LCM method. Find the LCM, the least common multiples. So, let's see how we can find the LCM. Now, the highest number here is 12. And 6 will go into 12 2 times. 3 also go into 12. 2 will go into 12. So, the LCM will be 12. Yes, or you can go by the approach that I taught you. You get the same thing. Now, 3 into 12, how many times? 4. 3, 4, 12. So, you multiply the 4 by the denominator 5. So, 5 times 4 is 20. 3 into 12 is 4. 4 times 2 is 8. 6 into 12 is 2. 2, 7, 14. 12 into 12 is 1. 1 times 1, 1. 2 into 12 is 6. 6, 5, 30. Okay, so with this, if we are to merge them or arrange them in ascending order, it's very simple. So 1 is the least, that is 1 corresponds to this. So we have 1 on 12. The next one is 8. Is the second one. So is the second one here. 2 and 3. And we have 14. That is that. 7 on 6. And we have 20. That is 5 on 3. And the last one is 5 on 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's that. Okay. Now let's talk about how to add fractions. Addition. Okay, so how to add fractions. Adding fractions are not difficult at all. Okay. For instance, when we have A on B plus C on D, so we have to find the LCM here. That will be BD. So you just take this number here or this variable here into the LCM. So B into the LCM will remove itself, leaving D. Then we multiply the result by the numerator here. It's not different from what we just did. So we have AD plus then D into the LCM will remove itself, leaving B. Then multiply it by this. So we have BC. So this is the result. Okay. Now, if we are to solve rare examples, 2 on 3 plus 1 on 4. So when you ask to add this, it's not difficult at all. So because the denominators are not equal, we have to find the LCM. What is the LCM for 3 and 4? 12. Okay. Why 12? Now let's confirm it here. We have 3. Multiples of 3, 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12, 3, 5, 15, 3, 6, 18. That order. 4, 4, 1, 4, 4, 2, 8, 4, 3, 12, 4, 4, 16, 4, 5, 20. So look at the least common multiples here. What is common? 3 no, 6 no, 8 no, 9 no. Okay, so we have 12. So, okay. Now, after getting your LCM, pick the first, okay, the first denominator of the first fraction, then divide the denominator, and then divide your LCM by it. So, 12 divided by 3, or 3 goes into 12. How many times? Okay. 3 goes to 12 4 times. 4 times 2 is 8 plus the sign. 4 goes to 12. How many times? 3. 3 times 1 is 3. So 8 plus 3 is 11. So 11 on 12 is the answer. As simple as that. So can pause the video and try the following. 5 on 7 plus 3 on 5. 1 on 2 plus 3 on 5. 6 on 3. 5 on 3 plus 2 on 3. So just try them. Okay, can try the following. It's not difficult at all. So that is that. Now when you are asked to subtract same thing, for instance 5 on 2 plus 1 on 2. So minus, okay, something like this. So we don't need to find the LCM because the denominators are equal. So we only subtract the denominators. So 5 minus 1 is 4. So we have 4 on 2. So 4 on 2 is 2. As simple as that. So with this, we can solve so many examples. So when we have 3 on 4 minus 5 on 8. Now let's observe this one carefully. So the denominators are not equal, so you have to find the LCM. And the LCM is 8 because 4 to 8. 4 into 8 is 2. 2, 3, 6. 8 into 8 is 1. 1 times 5. So 6 minus 5 is 1. So we have 1 on 8. As simple as that. Okay. So we can have so many examples. 2 on 9 minus 1 on 18. So you can try this one. Okay. All right. So that's that. So the next one, 4 on 11 minus 1 on 22. As simple as that. Okay, so that's the end of the lesson. Thanks for watching. All right.